Hey everyone, welcome to Cloud Masters. I'm your host, Matan Bordeaux, and we're joined by my co-host, Sam Clark, along with two Kubernetes subject matter experts, Lukas and Chimbu. There have been tons of great updates made in the world of Kubernetes, and we're here to highlight the top ones, who should care about them, and why. And the first one we want to talk about is Gateway API. It's something that we talked about in a previous episode with another Kubernetes subject matter expert, Alfred, when he was recapping his experiences at KubeCon Europe. But Chimbu, take us away. Maybe catch people up who aren't familiar with Gateway API, and we'll go from there.
Yeah, sure, Matan. Thanks for this opportunity. So I'll start with what is Gateway API. So the Gateway API is a set of resources in Kubernetes that model service networking in a more expressive and extensible way than the traditional Ingress API. So the necessity of the Gateway API arises from the limitation and complexities in the Ingress API. So as the modern applications become increasingly distributed and microservices oriented, so the need for more flexible and powerful way to manage the network traffic has become very critical. So in terms of the advantages, so why we need Gateway API, so what are the advantages it brings in? So the first one is like the Gateway API is provides more expressive and flexibility way of configuring your routing configurations. So it supports a wider range of features like header-based routing, traffic splitting, and traffic policies that are not currently supported in Ingress. So if you want to use this one currently in Ingress, you need to install an external service mesh solution. But now it's now possible to do natively in Kubernetes with the help of Gateway API. The other advantage is like the Gateway API separates the responsibilities between the infrastructure provisioners and the application developers. So it allows the infrastructure provisioners, like the platform engineers, to define the load balancer configuration. So they just define how the traffic enters into the cluster via the gateway resource. And while the application developers can focus on how their application should handle the traffic, so they can go and configure HTTP route custom resource or TCP route custom resource that allows them to like enable the things I mentioned before, like header-based routing or traffic splitting. So it provides the role-based API design configuration. And other thing is like this Gateway API is like designed for more extensible. It's allowing new capabilities to be added without disturbing the existing workflows. So you can add new configurations, new changes, new plugins without affecting your existing setup. And also the Gateway API enhances the security by providing more granular control over the traffic management policies and also supporting the implementation of security protocols more easily compared to the Ingress API. The last one I would like to mention is like the portability across multiple cloud platforms. So the Gateway API provides more consistent experience across different environments and cloud providers. So you just need to focus on your setup, and then you can able to easily migrate your configuration from one cloud provider to another cloud provider if it's required. So these are some of the advantages compared to the Ingress API.
Can you maybe give some examples as to like what use cases or situations really, like you talked about the limited routing capabilities for Ingress. In what situations maybe that you've seen in previous, in customers you've worked with, would something like the Gateway API have helped them?
Yeah, so let's start with the basic one. So we usually see like when you create an Ingress resource, it only allows you to implement like header-based routing for like you can provide like a host information in the Ingress API configuration, and then you can able to like some limited path-based routing. But with the Gateway API, you can able to do much more. You can able to base a lot of header-based routing. You can even split. You can implement traffic splitting. So the new version of the Gateway API now supports service mesh out of the box. So you don't need an external service mesh. So you can able to if you are running like multiple versions of the same service, you can now split the traffic. So it's easy to implement like a canary-based deployment now without requiring any additional service mesh. So that's one of the advantages in Gateway API over Ingress when it comes to the routing capabilities.
Something that's also important to add here is that with version 1.0 of the Gateway API being released, meaning there is stability in the API, this now also allows a lot more projects and tools to support and integrate with the Gateway API. Just today, the Argo project released a press release, for example, outlining Gateway API support in their Argo rollouts tool. which will come in very handy for DevOps teams that want to orchestrate more elaborate deployment strategies, for example. Chimbu, maybe you can give me some more an outlook here as somebody who is currently still using Ingress. I'm currently using Ingress Nginx, which you will be very familiar with, which carries a lot of its configuration in labels on the Ingress. How does it look like in Gateway API? What are the big differences here in terms of configuration?
Yeah, in Gateway API, everything configured through custom resource. Instead of labels in the Ingress, you need to create a custom resource configuration. For example, if you want to configure your the certification, or if you want to enable the HTTP to HTTPS redirect, you can now be able to through the front end validation custom resource. You have the configuration there, and then you specify which service it's actually linked to. So everything is configured through the custom resource. Similarly, if you want to configure some backend policy, load balancer policy configuration to your backend service, you can able to do the backend load balancer policy. So everything is through the custom resources I mentioned instead of labels. So it's easy to track. And it's also easy to, you can also easy to link this one with multiple services if needed.
Sounds great. So this means that my development teams will immediately get an error message in case of a misconfiguration when they try to apply a config change, rather than having to go through the logs of the Ingress controller.
That's exactly correct. Yeah, they'll get an immediate feedback that allows them to go and fix it immediately instead of waiting for a platform engineer or develop engineer to monitor the resource and then give feedback.
Sounds interesting. How does it look like with support for Gateway API across commonly used Ingress controllers or technologies?
So most of the almost all the open source Ingress controllers now supports Gateway API integration out of the box, like Nginx, Traffic, the call. You also mentioned about Argo rollouts, which is a pretty good add-on, which was released yesterday in November. So almost all proxy. So almost all the open source Ingress controllers supports Gateway API integration up to the box. If you look into the managed services like GKE also provides Gateway API support out of the box. With the AWS, you use the VPC Lattice to integrate the Gateway API. So now, since you mentioned Gateway API has released the 1.0 version, so it's more stable now. Almost all the cloud providers and open source Ingress controllers now supports Gateway API integration.
Should everyone just start using Gateway API, or is there kind of a line to draw with where Ingress, the normal Ingress, is fine for you versus no, you need to make the jump?
Yeah, the one key thing to remember is like Kubernetes is not adding any new feature to Ingress. So almost all the development now focusing through Gateway API. So if you're looking for any new features to be added, that will be added in the Gateway API instead of Ingress. Also, migrating from Ingress to Gateway API is like it's super easy. It's not very complex. You just need to understand which custom resource you need to use, and the documentation is very clear how to do the migration. The only thing is like the IP address will be a little bit different because it's going to provision a separate load balancer. So you need to update your DNS as part of the migration. Apart from that, it's super easy to migrate from Ingress API to Gateway API. And since it's more stable now, so I would recommend the user start using Gateway API and then start utilizing the advantages and features it offers.
So I've got a similar but slightly different question, and that's for those customers out there that are using. You mentioned service meshes may be no longer needed. So if someone's using Istio or something like that, is it now worth them dumping that and moving towards the Kubernetes Gateway API, or is it horses for courses? Is it stay with what you've got? How are we on feature parity? Those kinds of things.
So the service mesh support is in GA as of version 1.1, but not all service mesh features are currently available in Gateway API. So it starts with basics. You can able to implement like the canary. So the basic canary based routing you can implement, but if you're looking for more advanced service mesh capabilities like end-to-end encryption, like mutual TLS support, it's not currently available. So you can continue to use the external service mesh like Istio and Linkerd. As and when the new features get added into the Gateway API, you can take a decision whether you want to use Istio or you can just continue with the Gateway API. Also, in terms of the observability, so the service mesh, if you look into the external service mesh in Istio and Linkerd, it adds an additional infrastructure layer on top of the application layer. So it gives like additional visibility into how the traffic enters into your application and how it gets processed. So that kind of visibility is currently missing in the Gateway API because it's just part of the same Kubernetes networking. It's not an additional infrastructure layer. So you'll get more benefits from the external service mesh solution, but as you can see, like a lot of developments are actually happening in the Gateway API. So you can expect more features to be added in the service mesh in future.
Something else I recall, maybe to jump to our next, the next hot update, I guess, of recently. I think we talked about pod in place resizing. Is that something is that in GA? Is that something that's new, like and ready to be just used by everyone? Can you talk more about that?
Yeah, so the pod in place resizing is still in alpha. So this was released back in 1.27. So I expected that this will move to beta in 1.31. Check the roadmap. So if you look into Kubernetes itself, so one of the common question we get from our customers, like how to optimize the resource utilization for my workloads. Because when you deploy the workloads for the first time, you don't know how much memory and CPU you allocate to your workloads. Yeah, so you start with the small resource configuration because you don't know how much you need, but maybe that resource configuration is not enough for the particular workload. So you will see like some out of memory issues, application is not starting properly due to some crash loop backoff errors. So what you normally do is like you go and update your manifest and then you do the redeployment. So that will create a new replica set that will launch new pods. So that's like additional work. So sometimes, okay, you know that you deployed your workloads with current with valid resource configuration, but as the application up and running, you see like the resource usage varies. For example, it reaches 90% of the memory, and then it stays at 90%. There is no room between if there is any high amount of memory required. So what you normally do is like you go and update the resource configuration. So if your application is actually processing requests, so this will cause some disruption. So what the pod in place resizing feature offers is like you can go and update the resource configuration without you restart the container. So that's one of the key thing here. So you don't need to restart the container. You just make changes of the resource configuration, and then you can take a decision whether when updating the resource that the container needs to be restarted or not. So when you adjust the CPU configuration, so it's like more effective one. You don't need to restart the containers. So when you update CPU, it's taking effect immediately. But if you look into the memory applications like the Java application, you need to actually restart the container to get to in order for it to pick the memory configuration. So it's depending on the the program language you're using, whether you're using Java, you're using Node, you need and then you can take a decision whether you need to restart the container or not.
So if I'm a developer working with containerized applications, I don't need to worry anymore about downtime. I can just scale up and down based on changing demands, and it's one less worry.
Yes, that's correct. That's one less worry. You can just focus on your application development. If you see like you need to add more resources to your workloads, you just go and edit the pod resource. So that's one less thing to worry. So this reduces the downtime.
I feel like that was the original. Wasn't that the original kind of promise of Kubernetes?
Yeah, exactly.
Yeah, that's
why
correct.
why are we worried about this? What don't we just stick a load balancer in front of it and replace containers as we need to?
So yeah, that's the one. Yeah, that's the original promise of Kubernetes. Yeah, still need a load balancer to distribute your request across.
We can resize the load balancer without downtime.
Yes. Yeah, that's a good one. Yeah.
Yeah, but scaling is a good keyword here, Matan. There is a popular tool that's been used in the Kubernetes ecosystem for a long time called Vertical Pod Autoscaler, which does exactly this. It increases or decreases the compute or memory limits of minutes in a pod based on historical usage data. So if it sees that a pod is receiving more and more load, it will recommend an upsizing. In the past, this always meant a replacement of the pod with a larger resource limit. Now this can happen without terminating the pod while keeping to serve request or doing computation without interrupting it. So this is the big use case here for vertical pod autoscaling.
Got it. Because before that, I was kind of like, this was supposed to already be happening.
Yeah. Also, like one thing, as I said, like this feature is still in alpha, so it's not ready for production use case. You can go and play around in a development environment. So we already published a blog about this feature. You can test this in your development environment. We will include the link.
I'll share it in the I'll share it in the episode notes, the blog you wrote. So if once it gets into beta, can people, I guess, do you not, but generally, do you not really trust these new developments in production until it's in general availability, or do people sometimes deploy it while something's in beta?
So it's recommended to not use this in production until it's in GA, but have seen customers using the features when it's in beta because they want that one. Yeah, you can still use it in beta, but we don't recommend it. Wait for it in GA. If it's in beta, play around with it on the lower environments to understand more about how you can use this feature, and then wait for a GA to use it in production.
I think of that Austin Powers meme of like, I too like to live dangerously.
Yeah,
It's like
exactly. No risk, no
deployed
fun, right?
the beta version of in place of plot in place resizing.
It was the
Sorry,
worst that can
Lucas.
happen. Just your entire system goes down.
Yeah, Lucas,
Yeah.
you were going to say something?
In reality, it is going to be up to cloud providers mostly, in whether they support it, whether most users can actually use those features. So whether a feature is alpha, beta, or generally available not only relates to the stability of the underlying machinery and implementation, but also to the API and whether there can still be changes happening or changes need to be expected. Usually, cloud providers start supporting Kubernetes features as they move into beta stage, sometimes a bit later into GA stage. So this is what realistically most Kubernetes users will have to wait for, a feature like this going into beta stage, and then their cloud provider or their managed Kubernetes service provider supporting it.
Right. So for some of the things we're discussing on this episode, it's kind of like, keep this on your radar. Check if you're on AWS or Azure or Google Cloud, if the managed Kubernetes service there, look out for this to be adopted. If something that Chimbu or Lucas are saying excites you, or that you're like, oh, I want to start using this. So Gateway API, have at it. This thing, you need to wait a little bit.
It also depends on realistically, it depends on a risk benefits analysis. If you're spending a huge amount of time manually rescaling your pods, then maybe it's something that is worth the risk for you. We always sort of tend towards what's the supported and what's the safest option. But some companies aren't really that worried about that stuff. If they're running a personal blog or something like that, maybe it doesn't matter.
Any final thoughts on this one, on in-place resizing, before we move on? I just want to make sure I don't cut someone off.
This has been a long-awaited feature that both by users but also by companies providing tools for Kubernetes or in the Kubernetes ecosystem. This will really unlock a lot of interesting use cases, and I expect this to have a big impact in the landscape of Kubernetes tooling that we as cluster operators are working with on a daily basis. So I'm very much looking forward to what the future holds for this.
On to our next topic, which Lucas, you mentioned to me earlier, support or swap memory support. Can you talk a little bit more about this? Is this also in alpha?
Well, it's actually in beta now since Kubernetes 1.28. However, this doesn't necessarily mean that it's a good idea for everybody to use it. So you have to understand the historical reasons behind this. In the past, Kubernetes, or rather kubelet, the component of Kubernetes that runs on each node in the cluster and that is managing operations on the node, checked whether swap on the underlying Linux machine was enabled or not. And if swap was enabled, then it did not want to start up in the first place. The reason for this was that swap, which is basically using disk space, whether that's an SSD or a spinning magnetic hard drive, in order to swap out RAM, fast memory that is often limited, onto a slower but larger disk basically. So this has been used in the Linux world for quite a while, especially back in the days when RAM was still more scarce and more expensive. But this leads to many problems. Due to swap being much slower than RAM, this introduces a lot of entropy and a lot of unpredictability, how a workload is going to behave. There is also a lot of parameters that can be configured in a Linux system, how aggressively Linux should swap out RAM onto disk, for example. So a lot of unknowns, a lot of parameters that potentially have a lot of impact on how a container or a container orchestrated as part of a pod runs and behaves. So therefore, Kubernetes and the Kubernetes project said for the last almost 10 years swap is not a good idea for our use case. We are not supporting it. We even need to check whether it is enabled and abort starting up on a node if this is the case. However, there has been a bit of a paradigm change quite a while ago. In Kubernetes 1.22, a feature got introduced that adds a feature flag basically to kubelet, allowing cluster administrators to skip this check for swap, whether swap is enabled on the host system or not. So since then, theoretically, Kubernetes operators can join a node to a Kubernetes cluster also if swapping is enabled. And it is up to them how they configure the swappiness of the system. So because of the reasons that I mentioned earlier, swap space being much slower than RAM, it is still not necessarily a good idea for everybody to use this, even though it might become available at some point. There are certain specific use cases where this is an interesting feature though. If you think about operating a Kubernetes cluster in an on-premise environment, for example, where you cannot simply scale elastically, where you cannot simply add more RAM. However, you can theoretically use disk space in order to expand the amount of memory that is available to your applications. This might be a feasible trade-off and a good workaround. Also for certain types of calculation that require a lot of memory, but not necessarily fast memory, this can be interesting. For general purpose Kubernetes users that are using Kubernetes to run their web applications, maybe provide some other computations where they expect a consistent performance, this is probably not a good idea.
Not as clear cut of a yes, I guess, is what I'm trying to, as our last two suggestions, or as our last two highlights.
Yeah, also even though this feature is currently in beta, it's not actually supported in most of the managed cloud platforms. If you look into GKE, normally in GKE or EKS, when the feature is in beta, you can able to actually go and experiment. You can play around with this feature, but this feature is not available in any of the managed service platform now. You can able to play around with your own local environment for now, but as Lukas mentioned, it may not be useful for everyone. But something
I don't know that it makes a lot of sense in a cloud environment because obviously the cloud is unlimited in air quotes. But when you compare the pricing of the various instance types, and it's regardless of which cloud provider you use, the instances that use more memory are generally not much more expensive than the ones that use less memory. So, for example, in the AWS world, if you're using an M6, well, I won't use 6s because that's all Graviton, but if you're using an M5 instance, the AMD or the Intel ones, the pricing is about the same regardless of which amount of memory you use. So if you're using an M and comparing that to a C class or to an R class, which have sort of the doubling memory scale, the price is about the same. And it comes back to how many CPU you've got. Obviously, it's a little bit more expensive, but it's not really noticeable enough to really jeopardize the performance of your systems. And when you go into the Google world where you can specify custom sizes and add RAM as you wish to a system, the cost really isn't that prohibitive, I don't think, unless you're seeing customers maybe that do find that just to be the straw that breaks the camel's back.
Indeed, in a public cloud environment, this is one of the reasons why you're paying a hyperscaler a lot of money. You are just an API call away from adding more memory and from being able to scale out horizontally. But there are certain use cases where this might be applicable. For example, somebody that is running Kubernetes in an embedded environment, somebody that is running Kubernetes on top of a container ship or somewhere where hardware is finite and is limited, but you might want to run some big data operations, for example, that require more memory. Also, within AWS, if you think about instance types, so first of all, it's an even worse idea to use network block storage for swap than it is to use a locally attached disk. But nowadays, SSDs have become pretty fast with NVMe and PCIe attached SSDs. You get relatively high throughput memory compared to 5 or 10 years ago. So in AWS, there are certain instance types as well that come with a locally attached NVMe SSD that gives you still slower than RAM, but reasonably fast and performant memory. So here, this could still be an interesting trade-off.
So I'm not as scared as I was, because when I saw this topic in the notes, it gave me flashbacks to running Citrix servers in the old days and Windows. And And back then, the recommendation from Microsoft was that a page file had to be like RAM plus a little bit, can't remember the exact equation, in case of the system crashing and needing a full page dump. A full memory dump. So we used to have guys when I worked at Citrix, had guys whose job it was to analyze those complete screen dumps. So I'm very glad we're not going back into that space. The only other time I've ever used page files in Anger was when I couldn't get Duke Nukem 3D to run on my 486 back in the day, you know.
So we, in a previous episode, I think Chimbu, you might have been on Kada, Kubernetes event-driven autoscaling. We now have another way to autoscale, and that's container resource-based autoscaling. And we just discussed how in-place resizing can quickly adjust pod resource allocation. How does this fit into the picture? When would you use this over in-place pod in-place resizing?
Yeah, that's a good one. So usually when you enable the auto scaling for the Kubernetes workload, you go with like HPA. And one of the common question we receive from our customers, like especially when they are running multiple containers in the same pod, they come and ask like, okay, I have configured HPA, but I don't see any scaling up, and I can see the application container is running like 90% memory or 80% memory. It's above what I configured in my HPA, but it's not scaling. Why? So normally, if you look into how HPA is calculating the resource usage, it's actually calculating. It takes the average amount of the resource usage of all the containers running in the same pod. For example, if one container is consuming more resource and the other container is consuming less resource, it just takes an average, and then it may think like, okay, the average utilization is less than what is specified in HPA, and so I'm not going to scale it. So that's a common problem we usually see. So it's not the HPA is not actually seeing the true picture happening within the pod. So the container resource without a spelling is going to solve it. So how it looks like it's going to, you can now able to configure HPA to look for the specific container resource usage instead of taking an average. It looks for a specific container, and then it will take an auto scaling a decision whether it needs to scale or not. So for instance, so let's say your sidecar container running in the same pod that processing logs that are produced by your application. So for that one, it might not consume significant resources. All it does is like it just takes the logs and it's processing the logs produced by the application. So if you look into the resources, it's not huge. But the main application that actually processing the customer request, that will be the one consuming a lot of resource. So you need to scale based on the main application container instead of taking the average of these two containers and then scale it. So now you can able to scale by specifically looking into your main application container. So that's the problem it's solved. So you can now just and one good thing is like this feature is now unstable from version 1.30, so you can now use it in production. You can now configure your HPA to be more accurate and then scale based on the actual application container usage. You can able to integrate with Kava as well.
So less time manually intervening. If you're a DevOps person, for instance, manually intervening into making sure that main container has the right amount of resources, and I also
comes
see
back to the bugbear we said. Sorry, Matan. It comes back to something that we said in a previous episode about autoscaling Kubernetes. There wasn't very much auto in the autoscaling, and this seems to be getting us back in that direction now, right?
Yeah, so with both these in-place pod resizing and container resource-based autoscaling will simplify how autoscaling is going to work. So you can now able to, with in-place pod resizing, you can now able to dynamically update the resource usage. And then if more resources are needed, you can just add it, and then you can adjust the HPA, and then your HPA can see the true picture of what's happening inside the pod, and then take scaling decision. When the Kata comes in, you can now able to even scale with the external metrics. You don't need to depend only on CPU and memory, because by default, HPA will only see CPU and memory. At the container level, by default, you can only able to configure CPU and memory. So HPA can able to scale by looking into the CPU and memory, and you can also bring in Kena, and then you can bring some external metrics like the amount of requests it receives, and if your application also producing some custom metrics, you can also able to use the custom metrics with the Kena, and then you can able to take a scaling decision. So the container resource without scaling plus Kena gives you like more sophisticated way of scaling your application instead of doing the traditional scaling based on CPU and memory.
I imagine some operator who maybe started with Kubernetes 7 years ago is now looking cynically at someone starting today with just the riches of options they have for scaling, for auto scaling in this case, right?
That's correct. Yeah. So when it comes to the autoscaling, it evaluated a lot over the time. So it uses a lot of flexibility now and a lot of features and then you can take a better decision.
The sidecar pattern that Chimbu has described earlier is something that has been popular for a long time. This is a very powerful design pattern when composing applications out of multiple containers. But the big problem for many users of this was always lack of granularity when it comes to metrics and scaling. This is really where this comes in. This is going to be particularly interesting, for example, for users on a PHP stack, where it is very common to have a web server like Nginx combined with a PHP process manager like PHP FPM in a separate container. They have very different resource requirements. And in the past, it was very difficult to efficiently scale if you had both in one pod in a sidecar pattern. Now, what you can do is you can point to HPA, to PHP FPM, just look at those metrics and scale based on this, because you know that everything that Nginx does is forwarding requests and sending responses. Therefore, we need to focus on the PHP container.
Now, I think our last feature, our last kind of thing to look out for in terms of Kubernetes release, I think it's user namespaces. Lukas, you want to share more on I guess, why should we care here?
Yeah, so user namespaces is a feature that has been in alpha stage since Kubernetes 1.25. And now just very recently, in the recent release of Kubernetes 1.30, has graduated to beta. Now, this is something that is of particular interest to the more security-conscious Kubernetes users out there, and to people who want to prepare for a potential container escape through an attacker. So what this feature, like in the past, when using Kubernetes and orchestrating containers on it, the container runtime itself was running as user root. Containers started up by this container runtime had their own process namespace. Therefore, from their perspective, they could run processes as root or as user. However, when they escaped this containerization, they were still able to exercise root permissions over the host. With this new feature that ties into features in the Linux kernel, C groups too mostly, it makes it possible for the container runtime to map a user UID to a container instead of the root UID to a container on the host. So this means that even if an attacker is able to escape your container, your containerization, they will still only have limited access and limited permissions on the host. They cannot read system-wide configuration files. They cannot access TCP sockets, for example. They are constrained into the permissions that this user had. This is something that, since it's now in beta, is not yet supported by any of the big managed Kubernetes service providers, but I expect this, as support gets rolled out in the future, to maybe even become the standard for how mapping of user namespaces between host and container is being done. The problem that is currently preventing this from being adopted widely is that most of the widely used open source container runtimes are not yet supporting it. So first of all, this is a Linux-only feature because it requires Linux primitives like namespaces. There's no support for this on Windows, for example. But also container runtimes don't support it yet. Amazon's AWS's managed Kubernetes service EKS, for example, uses containerd, which does not support it yet. But as soon as we will see support for this in more container runtimes, then I expect this feature to be more widely adopted.
Yeah. So as Lucas mentioned, this is another great feature to reduce the damage of a compromised container can do to the host or other parts in the same node. So most of the time we see like customers reporting like DDoS attacks when you check. So they without knowing it, they just name whether they were running the container as a root user or running or providing more highly privileged access to the security context. So this user namespace will limit if this container is particularly compromised. So it's one of the great addition to the security.
It's actually, I mean, as you talk about it, it's something that it surprises me that it's actually been the other way around for so long. That Kubernetes was able to prosper so much or proliferate so much, possibly better said, when it's running in a system context, globally on so many systems. It's such a thing that even when you're reading a basic guide on how to set up Apache on a home server or something, the first thing it says is create a www data user and use that. Don't run it under the system context. So
it was widely discouraged, and it has been well known for a long time that that if running a container, at least you should drop privileges for these containers compared to the host system. There were a lot of use cases, and there are still some use cases where you need privileged containers that need to have privileges over certain pieces of hardware attached to the machine, certain system-wide capabilities to manage other processes or have insight into what they are doing. So there are still use cases for privileged containers. That's why you also need a way how to, assign those privileges on the host. So this is where your container runtime needing to be privileged comes in. But this feature now allows you to basically not start with root and then have to drop privileges, but rather clearly map a user ID on the host to a container.
When this eventually gets into GA, what second or third order effects do you anticipate? Is there anyone not adopting Kubernetes because this doesn't exist, for instance? What do you anticipate kind of happening?
The users that will be particularly keen to get their hands on this are, of course, users in regulated industries, especially if their clusters are containing customer data, patient data, those sort of things. Also, SaaS companies that are running a product in a multi-tenant way on a Kubernetes cluster, where multiple customers are hosted on the same cluster, maybe even sharing the same compute node underneath, will be quite keen to get their hands on this. This is something that is supported in Linux. This is something that doesn't have much implications besides giving them the advantage that a potential breakout scenario is well covered by having a user, not the root and not root permissions.
Got it. Well, I think we talked about 5 key topics. So unless there's any last words, I think we can wrap things up here. Any final comments on anything that we've talked about, or even this one about user namespaces?
No, from my side.
Cool. We can listen. That's also fine. I'm not trying to set anyone up here. So, anyways, thanks everyone for listening / watching. If you're not using the Gateway API already, you should. Am I safe
at least
to say
start
that?
checking it out. Yeah.
So at least start checking it out. Some of these other developments, keep them on your radar as they move to GA and as the managed Kubernetes providers start adopting it themselves. And have a great day.
Thanks everyone.
Thanks, everyone.
Oh, never good. Bye-bye.